All right, so what we are talking about in this last section is what's called arithmetic and geometric sequences. We're dealing with sequences here. So the first question that needs to be answered is, what in the world is a sequence? So we're going to define that. A sequence of numbers is a list in which each number is related to the previous one by some sort of rule. Okay, and in math, there's lots of different examples of sequences. In your sequence, each number is called a term of the sequence. That way, when you hear that word, you know what I am referring to. So one of the most famous sequences in math is called the Fibonacci sequence. I don't know if you have ever heard of that or know much about it. But we're not going to spend a whole lot of time talking about it. This is just a fun example. And in the Fibonacci sequence, you get each next term by adding the previous two. So we start off with a 1 and a 1, and then you can see that the next term you get by 1 plus 1 is 2. And then the next term is 1 plus 2 is 3. So you're always adding the two previous terms to get the next one. And so then 3 plus 5 gives you 8, and 5 and 8 gives you 13. And going on down the line, 21 and 34 gives you 55, and 55 and 89. The next term, if we were so inclined, would be 144. And then you could keep going on. Sequences don't have an ending. You can talk about a particular part of a sequence, but the rule, whatever that rule is, just keeps going and going. So again, notationally, in my Fibonacci sequence that we just defined right there, the first term, what we do to denote the terms is usually the letter A is used and a little subscript. That means the first term. In this one, the first term is equal to the number 1. The second term, A with a subscript 2, this is also equal to the number 1. The third term, A subscript 3, that is equal to the number 2. And then A4, that's as far as I'm going to go. The fourth term is the number 3. And you can keep going on and on and on like that. So that's just a real quick little primer on what a sequence is and some of the notation. So far, so good. We doing okay? All right. Well, for us in this class, we are going to talk about two types of sequences, and they're kind of the most basic types of sequences, just because we're getting our feet wet with this. The first one that we're going to talk about is called an arithmetic sequence. And what makes this an arithmetic sequence is it's one in which each term differs from the preceding one by a constant amount. The amount is called the common difference. So going from one term to the next term is always the same amount. And so that is called the common difference. So for example, my example one right here. What we're going to do, just to get used to this idea of what a sequence is, and in this case, an arithmetic sequence, we're going to write the first 6 terms of the arithmetic sequence with a first term of 7 and a common difference of 4. So the first term right here of 7, that is going to be my A with the little subscript 1, the way we notated it. A1 of 7 and a common difference of 4. When you're going through some of the problems, instead of saying the words common difference, we'll use the letter D for difference. Okay, just so that you know what the notation is. All right, well, I don't think this is too difficult of an exercise, but if you have a question about it, definitely let's get it cleared up. So the first term is just going to be 7. And then since the common difference is 4, you're just going to now add 4 to get each successive term. So 7 plus 4 is 11. There's term 2. 11 plus 4 is 15. There's term 3. 15 plus 4 is 19. I'm tired of talking. What's the next term going to be? 23. Fantastic. That's 5 terms. And then the next one is 27. And you can go on and on and on if you want, but the question just asked for the first 6 terms. So we will stop our endeavor right there. Well, you practice this. The exercise 1 gives you the same sort of thing. Write the first 6 terms of that arithmetic sequence, please. All right, in this particular problem, I gave you the information symbolically rather than stating it out, just so that you see it both ways. So what is the first term of my sequence going to be? 14, great, that's the A subscript 1. 14. The common difference is now -3. So when I add -3 to 14, what's term 2? 11. Then what's term 3 going to be? Great, you're doing excellent. Term 4, 5, term 5, 2, and then term 6, -1. And again, you could keep going and going and going, but we were just asked here for the first 6 terms. Okay, so that is, I mean, I don't think that is the most difficult thing we've done this semester is highlighting the terms of the sequence. If you have a question, ask it. So then the next thing that we're going to answer is, okay, well, what if I don't care about all the values of a sequence? What if I just want a specific one? Well, there is a way to figure out the nth term of a sequence, and it's given by this little formula right here. Now, you do need to remember this for the test. That's not going to be given information. You know my policy is I don't like to give you an excessive amount of formulas to remember, but there are going to be 2 in this last section. So you got to remember this. So what this says is that the nth term, whether it's the 50th term or the 100th term or whatever, is equal to the following. It's equal to the first term, A1, plus n minus 1 times the common difference. We're going to do this in just a minute, but I think the interesting part of this is, how do we know this? Where in the world does this come from? Well, the way we know this is we're bringing back something we've done a couple times in this semester. We're going to use some inductive reasoning. And we're going to find the pattern, and we're just going to extend the pattern. So if we did go to list the terms, okay, the first term we know is going to be A with a little subscript 1. Well, in an arithmetic sequence, what you do to get each subsequent term is you just add the common difference. So the second term is going to be A1 plus the common difference, which is D. Then the third term. Well, to get the next term, I'm going to add D to the second term. So if I have A plus D, and then I'm going to add another D, another common difference, that's going to be A1 plus what now? 2D, yes. Because I took this second term, A plus D, and I added another common difference, another D, so that makes 2D. Okay, so then maybe now the pattern's becoming a little more clear. We'll try again. So now if I want the fourth term, I'm going to take the third term, which is A plus 2D, and I'm going to add another D to that. And so what do I get for the fourth term? It's A1 plus 3D. Let's do it one more time, and then I'm hoping that the pattern will click in. The fifth term, okay, well, the fifth term, I'm going to take that fourth term, A1 plus 3D, I'm going to add another D. So that's going to be A1 plus 4D. And what you can see, and here's where the inductive reasoning comes in, is that every one of these terms has A1 in it. Okay, that's why our general formula has A1 in it. And then notice, for each term, the number of D's, the number of common differences, is one less than the term. So for the second term, there's 1D. For the third term, there's 2. For the fourth term, there's 3. It's always one less. And that's why up here, this is n minus 1. It's one less than the term that you care about. Okay. Whether that was enlightening or not, if you can remember the inductive reasoning, if you forget the formula in the stress of the test, that will help you, bring it back to memory. One way or another, you've got to remember it. So here we go. This is example 2. Example 2 right here. I'm going to do this one. What we're going to do is we're going to find the 8th term, or the that doesn't look like I spelled it right. Is 8th spelled right there? What did I do? Oh, there's no EIG. I don't know. It just looks, you ever look at a word and this looks wrong? That word looks wrong to me for some reason. Okay. Spell checker said it was fine, so it must be fine. Okay, we're going to find the 8th term of the arithmetic sequence whose first term is 4 and the common difference is -7. Okay, so we're going to find the 8th term. Now I know I've only done the 8th term. We could list it out, but we're going to do this without listing it out. So here we go. The 8th term, A with the subscript 8, is equal to the first term, which is 4, plus n minus 1, which is the number of terms minus 1. Now, you can skip this part, but I'm just going to write this thoroughly for your notes. So it's 8 minus 1, or in other words, 7 common differences. And the common difference is -7. I'm going to put that in parentheses so that I don't forget that I'm multiplying by that. And now it just becomes a calculator problem. So I've got 4 plus 7 times -7. That's 4 plus -49. And 4 plus -49 is -45. So if I was to make a list and start with the term 4 and add -7 to it successively, I would end up at -45. That's the 8th term. What I'd like you to do in exercise 2, find the 9th term of the sequence that I described there, please. Also, some good news you can be really happy for me about is I just learned how to spell 8th. Okay, I'm 53 years old. I've just learned this. I think one of you whispered, but you weren't super confident that I was missing an H. So my phone told me it's EIGHTH. So whoever's watching this video, yes, you can delight in my lack of spelling ability. So, all right, exercise 2, here we go. We're going to find the 9th term. So we're going to find A with the subscript 9. And that is equal to the first term, which is 6 plus, and since I'm finding the 9th term, I'm going to do 9 minus 1, or 8 common differences. And the common difference is -5. It's, again, another sequence that gets smaller and smaller. So that's 6 plus 8 times -5. 8 times -5 we know as -40. And 6 plus -40 is equal to -34. Now, again, that wouldn't have been too laborious to list out the 9 terms, but if I was to ask you, or if the homework was to ask you what the 50th term is, the formula works just as well and just as easily on something that you wouldn't want to list out that many terms for. So exercise 3 is just another example to reinforce the same point. So go ahead and do that one. All right, so just going to go ahead and do this. This time we're finding the 12th term, so A with the subscript 12 on this particular problem. And in this case, the arithmetic sequence has a first term of 9 and a common difference of 7. So the first term is 9 plus. And then what I'm going to do is I'm going to take 12 minus 1, or 11 common differences. And then that common difference in this time is 7. Before I go and do the arithmetic, is everyone doing okay? Any questions, comments, concerns about either what an arithmetic sequence is, how to list the terms, or how to find a specific term? We doing okay? All right, so then the arithmetic on this is 9 plus 11 times 7. Order of operations tells me to do that multiplication first. So that's 9 plus 77, and 9 plus 77 is 86. So if I listed out all those terms. All right, so that is an arithmetic sequence. That's the first time. That's actually the most basic kind of sequence that you can have, is just by consistently adding the same thing. The other type of sequence we are going to address in this class is what's called a geometric sequence. In this case, a geometric sequence is one in which each term is found by, in this case, multiplying. So the big difference here is that we are multiplying instead of adding. So we're going to multiply the previous term by a fixed non-zero constant. So fixed means that the number that you're multiplying is not going to change. And then non-zero means it's any number but 0, because if you, as we know, if we were multiplying by 0, every term would just be 0, and that's not a very fun sequence at all. So we're going to multiply by a fixed non-zero constant. This constant is called the common ratio. Okay, that is what, when we're multiplying instead of the common difference, it's called the common ratio, but it functions the same. So example 3, my example of a geometric sequence, going to go like this. We're going to find the first 6 terms of the geometric sequence with a first term of 6 and a common ratio of 2. All right, here we go. The first term is 6. And since the common ratio is 2, we're going to multiply each term by 2 to get the next one. So 6 times 2 is 12. 12 times 2 becomes 24. 24 times 2 becomes 48. And you can see these terms are getting large rather quickly. 48 times 2 is 96. And then I asked for 6 terms. So one more time, 96 times 2, whatever your calculator would tell you for that. feeling a little lazy today since we're just about to go into a holiday. So, whoops, I don't even know what I just did there. So 96, I can't use my calculator either. All right, that's 192 is the sixth term. And then you could keep going if you wanted to, but we're stopping there. All right, so what I would like you to do is exercise 4. I give you a different first term, a different common ratio, and you're going to do the first 6 terms of that sequence, please. So the question, in case you didn't hear it, is do we want this in decimals or fractions? This one, decimals would work fine because you're multiplying by a half, so you're always going to get a terminating decimal. But I would say go ahead and practice the fractions, because if it was 1/3, now we have a repeater, and it would be harder to represent as a decimal and keep doing the multiplication. Now remember, multiplication is the one, I think, operation of fractions that we are the most comfortable with. And to multiply fractions, you multiply tops, you multiply bottoms. That is what you do when you get to that phase where you have fractions here. So on this particular problem, the first term is 12, so we'll start off there. And then the common ratio is a half. So if you need to write out your work, that's totally fine. I'm just going to use below this as my scratch work here. So when I multiply 12 times a half, if that's not just arithmetic you can do in your head, so that I'm going to take the 12, which is 12 over 1 times a half. And remember, when you multiply your fractions, you multiply tops and bottoms. So 12 times 1 is 12. 1 times 2 is 2. 12 over 2, well, that reduces to 6. That's my second term. Third term, I'm going to take the 6, multiply by a half. Again, if you need to do this work and write it out, that's great. That's why God gave us pens and pencils. So 6 over 1 times 1 over 2. So that makes 6 times 1. The top is 6. 1 times 2 is 2. So 6 over 2, that reduces to 3. The fourth term, I'm going to take the 3 over 1 times 1 over 2. 3 times 1 is 3 in the top. 1 times 2 is 2 in the bottom. That doesn't reduce, so I'm just going to leave the fourth term as 3 over 2. The fifth term, I'm going to take the 3 over 2, and I'm going to multiply it by a half. So again, tops and bottoms. 3 times 1 is 3 in the top. 2 times 2 is 4 in the bottom. That doesn't reduce at all, so my fifth term is 3 over 4. And then finally, I asked for 6 terms, so I'll do it one more time. So I have 3 over 4 times 1 over 2 again. Again, tops and bottoms. 3 times 1 is 3 in the top. 4 times 2 is 8 in the bottom. So the sixth term is 3 over 8. And you can keep going and going. Yes. Yep. You just use the mixed number, 1 1/2, or if you did a decimal, 1.5. In general, in math, I don't really deal with mixed numbers, because then to multiply the next one, you got to then make it back into a fraction and then multiply again. So mixed numbers get a little bulky. So I just kind of avoid them and keep the fractions improper. But on the test, if you wrote down the mixed number, 100%. Okay, it's not wrong. Okay. Great question. All right, do exercise 5. It's another one with a fraction just for kicks. Do the first 6 terms with that common ratio and that first term. All right, well, let's see how you did on multiplying these fractions. I probably think that actually developing the sequence is not that terribly tricky, but the multiplying the fractions is probably the part that you might stumble on here. So the first term is 20, so we start there. And then the common difference is, or excuse me, the common ratio is -2/5. So here we go. So the first one, 20/1 times -2/5. It looks like this. So again, multiplying fractions is just tops and bottoms. So 20 times -2 is -40. 1 times 5 is 5, and -40/5 is -8. That is term 2. Now I'm going to take the -8, so -8/1 times -2/5. So tops and bottoms, -8 times -2 is +16. 1 times 5 is 5. I'm going to leave it like that. If you made it a decimal, that's perfectly acceptable. So 16/5 is the next term. And then the 16/5 times -2/5. This is going to give me my fourth term. And so 16 times -2 is -32. 5 times 5 is 25. So -32/25. That's my fourth term. And I'm going to do this 2 more times. So then I've got -32/25 times -2/5. So -32 times -2 is +64. 25 times 5 is 125. So that's +64/125. And last but not least, the 64 over 125 times the negative 2 over 5 one more time. Tops and bottoms, 64 times negative 2 is negative 128. And then 125 times 5 is 625. So we've got negative 128 over 625. And again, you can do that as many times as you want, but we are going to be good with 6 times. Yes. Uh-huh. No, in mine, the whole fraction is negative. I've just kind of written the negative with the top, but it's, remember the rules for, because fractions are just division. So the rules for division, even if I have my negative with the top, a negative divided by a positive is a negative value. Okay. The only thing that would be wrong here is to have a negative with both the top and the bottom. Because if you have a negative with both the top and the bottom, a negative divided by a negative, that's a positive. So you've changed the sign of it. Okay, so great question. Good to be sure of these things. Any other questions? We doing all right? All right, we'll tend to round this out. What we're going to do with the geometric sequence is the same thing that we did with the arithmetic sequence. We're going to say, okay, that's great to list out the terms of the sequence, but what if I just want one particular term? Well, then again, we have a very similar formula to what we had for the arithmetic sequences. Again, you need to remember this. Okay, that's not going to be given to you on the test. You're going to have to do that. And so what this says is for the nth term of a geometric sequence, what you do is you take the first term, and since in a geometric sequence you multiply, we're going to multiply it by that common ratio. And again, very similar to the arithmetic sequence, now we're going to multiply it one less time than the number of terms that they're the term number that we want to find. Again, how do we know this? We can use inductive reasoning. The first term is a with a subscript 1. The second term is a with a subscript 1 times r, because that's what you do in the geometric sequence. We're going to multiply every time. So to get every successive term, we're going to multiply by r. So the third term, when I do that, that's going to be a to the 1 times what? What do you think I'm going to multiply that one by? Yep. I'm going to take the second term, a subscript 1 times r. I'm going to multiply by another r. And so r times r is r squared. The fourth term, I'm going to take the third term. I'm going to multiply the third term by another r. So that's going to give me a subscript 1 times what? R third. Yes, we're finding the pattern there. One more time, just because we did it 5 times before, let's do it 5 times this time to be the same. And so to find the fifth term, I take the fourth term times r. Well, the fourth term is a1 times r to the third. And when I multiply that by another r, how many r's do I have now? 4. Yes. And so you can see, just like before, the pattern is this. Every term has a subscript 1. That's why the formula has a subscript 1. And then the number of r's is 1 less than the term number. So in the first term, there's no r. The second term, there's 1 r. The third term, there's r squared. Fourth term, there's r to the third. Fifth terms r to the fourth. And so you could keep going on. And that's why inductive reasoning, that's where we come up with a1 and then r, 1 less than the term number I'm finding. I'm going to do one, then I've got 2 for you to do. And then if you have any questions about this, you can feel free to ask anything at all that you want. And then we will be just about done. So example 4 says we're going to find, again, I've spelled eighth wrong. I'll have to go back in and fix that, but you can, I'm just so cute and adorable. So find the 8th term of the geometric sequence whose first term is 4 and a common ratio of 2. All right, so we are finding the 8th term. So a with a little subscript 8. And according to the formula up above, the 8th term is equal to the first term, which is 4, times the common ratio, which is 2, to the power of n minus 1. So that is 8 minus 1. I'm just going to write that out so that your notes are thorough. but you can skip that step and go right to 2 to the 7th power if you want. All right, so that means when I simplify that, that's 4 times 2 to the 7th. Now remember order of operations, we talked about that. We do the exponent first. So I go into my calculator and go, okay, what's 2 to the 7th power? 2 to the 7th power is 128. So that's 4 times 128. And 4 times 128 is equal to 512. So if I was to list out the terms, the 8th one would be 512. All right, I would like you to do exercise 6, please. Oh, and when you do this, let me just make a note. I should have typed this. Round your answer to the 100th. We'll do that on both of these last problems. All right, so we're finding the 9th term this time. So A with a subscript 9 is equal to the first term, which is 5, times, this time the common ratio is 1.5. So I'm just gonna put that in parentheses because it's the decimal, 1.5, and the power is gonna be 9 minus 1, or in other words, 8. So just simplifying that, that's 5 times 1.5 to the 8th power. I'm probably not going to write down what 1.5 to the 8th is because it's going to be a significant decimal. So we'll do 1.5 to the 8th, and that turns out to be that right there. So I'm just going to take that, and then I'm going to multiply that by 5. And then I'm going to round to the 100th, which is the second decimal place. So I've got 128.144. The 100th is that first 4. And so when I round, that's going to be 128.14. I don't round up in that case. Everybody with me? All right, well then this is the last problem for this section. So go ahead, exercise 7, same thing, just this time we're finding the 12th term and I've changed the common ratio. Be careful because that common ratio is negative. All right, well, let's see how you did on this, and then we'll answer any questions that might be out there. So we're going to find the 12th term, so A with the subscript 12. And so that is going to be the first term, which is 145,000 in this case. And then times the common ratio, negative 1.05, and to the 12 minus 1, or the 11th power. So again, I'm just going to go to my calculator. So here it is. There's my good buddy. So I've got, I'm going to do negative 1.05. I'm going to raise that to the 11th power. Notice in my calculator, I did put that in parentheses. We talked about that when we talked about order of operations, that when you have a negative that you're raising to a power, the parentheses matter. And the parentheses are telling me that the negative is part of the number that I'm raising to the 11th. Okay, so I do that and I get this number right here. I'm not going to hit clear. I'm not going to round yet. I'm going to now multiply because my calculator does have the exact answer remembered. So now 145,000, and I end up with negative 247,000. No, I had an extra zero. Man, the hits never stop coming. Let's try this again, everybody. I was on a roll, too. I was doing so good. All right, now we're going to multiply by 145,000. So just 3 zeros, not 4 zeros. Perfect. There we go. So now the answer is negative 247,999.2069. And rounded to the 100th, I'm going to round that 0 up to a 1 because the 6 right there. So it's going to be negative 247,999.21. That is the approximate term when I've rounded.